Number 10. The 60-based number system. Every time you check the time, you are using a Babylonian mathematical decision. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. These numbers are not accidents of history, not arbitrary conventions, not the product of any modern calculation. They are the direct inheritance of a mathematical framework developed in Babylon around 4,000 years ago, and they survived the collapse of every civilization that used them, passing through Greek astronomy, Roman engineering, and Islamic mathematics, until they became so embedded in how the world measures everything that no one questions where they came from. The Babylonian sexagesimal system base 60 was not chosen randomly. 60 has more divisors than any smaller integer. It divides evenly by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. For a civilization whose primary mathematical challenges were distributing grain rations, calculating land areas, and tracking celestial cycles, a number that divides cleanly in so many ways was not a philosophical choice. It was an engineering solution. The system disappeared from explicit use when Babylonian civilization was absorbed into the Persian Empire and eventually forgotten. But it had already been adopted by Greek astronomers who used it to divide the sky. And from Greek astronomy, it passed into the Islamic mathematical tradition, and from there into European scientific practice, until, in the 14th century, the mechanical clock divided the hour into 60 minutes, because that was the system the clockmakers inherited. You are reading this on a device that tells time in a Babylonian number system. The clock on your wall is a direct descendant of a mathematical decision made in ancient Mesopotamia. Number 9. Trigonometry. For most of the 20th century, trigonometry was credited to the ancient Greeks. Hipparchus of Nicaea, working in the 2nd century BC, was identified as the founder of the discipline, the first person to systematically study the relationships between the angles and sides of triangles. In 2017, mathematician Daniel Mansfield of the University of New South Wales published a paper in the journal Historia Mathematica that moved that date back by more than 1,000 years. The Plimpton 322 tablet, a small clay tablet purchased in the 1920s from an antiquities dealer in southern Iraq and held since then at Columbia University, had been recognized since the 1940s as containing something mathematically significant. It shows 15 rows of numbers in 4 columns, written in cuneiform using the sexagesimal system. Researchers knew the numbers were related to right triangles. What they could not agree on was what the tablet was actually for. Mansfield's analysis determined that it is a trigonometric table, a systematic list of ratios for right triangles at decreasing angles, organized in a way that allowed Babylonian surveyors to calculate land boundaries using what we now call the Pythagorean theorem. The tablet predates Pythagoras by approximately 1,000 years. The Babylonians did not develop trigonometry for astronomy, as the Greeks did. They developed it for surveying land, for the entirely practical problem of determining where one person's field ended and another's began. The mathematics that underlies navigation, engineering, architecture, and physics today was first formalized not in a Greek philosophical tradition, but in a Babylonian land registry office. Trigonometry disappeared from explicit knowledge when Babylonian mathematical texts were lost. It was reinvented by the Greeks from first principles, transmitted through Islamic mathematicians who developed the sine and cosine functions, and entered the European mathematical tradition in the medieval period, reaching the same conclusions by a different route, 1,000 years after Babylon had already been there. Number 8. The world map. Around 600 BC, a Babylonian scribe drew a map of the world. The Imago Mundi, held today in the British Museum, is a clay tablet approximately 12 centimeters across, showing a circular Earth with Babylon at its center, the Euphrates running through it from north to south, surrounded by a circular ocean, with a number of identified regions arranged around the central landmass. Beyond the outer ocean, the map shows triangular projections regions described in the accompanying text as distant, mythological, and difficult to reach. It is the oldest surviving world map in human history. What is remarkable about the Imago Mundi is not its accuracy. It is schematic and conceptual rather than cartographic, but its intellectual ambition. The decision to represent the totality of the known world as a single unified image, with a defined center and a defined edge, is a specific cognitive achievement. It requires conceiving of the world as something that can be seen from outside, something with a shape and a structure that can be captured in 2 dimensions. This conceptual framework, the world as a mappable object with a defined center and a measurable periphery, is the foundation of cartography. Every map ever made begins with this assumption. The tradition of world mapping disappeared after Babylonian civilization was absorbed into successive empires. Greek geography produced sophisticated maps, but drew on different traditions. The Babylonian map itself was buried in the ruins of Sippar for over 2,000 years, before being excavated in the 1880s and eventually transferred to the British Museum. The oldest world map is in London. It was made in Babylon. And the intellectual framework it represents, the world as something that can be drawn, is so fundamental to how humans think about space that we have forgotten it had to be invented. Number 7. Astronomical prediction. The Babylonians were the first civilization to distinguish between astronomical observation and astronomical prediction, between recording what the sky does and calculating what it will do. Over roughly 7 centuries, Babylonian astronomers accumulated observational records of the moon, the sun, the 5 visible planets, and specific stars. These records, preserved on clay tablets and known collectively as the Astronomical Diaries, documented celestial positions with a consistency and precision that later Greek and Islamic astronomers described as foundational to their own work. But the Babylonians did not stop at observation. They developed mathematical models, arithmetical sequences, and combinations of sequences that allowed them to calculate future positions of celestial bodies without continued observation. They could predict lunar eclipses. They could calculate the future positions of Jupiter. They could determine in advance the dates of planetary conjunctions. In 2016, historian Matthew Osendriver of Humboldt University, Berlin, published a paper in the journal Science, demonstrating that Babylonian astronomers had used a method of calculating Jupiter's position by computing the area under a curve. A mathematical technique that European scholars believed had been invented in the 14th century AD as a precursor to calculus. The Babylonians were doing integral calculus, applied to astronomy, approximately 2,000 years before European mathematicians formalized the concept. This knowledge was lost when Babylonian civilization ended. Greek astronomy drew on Babylonian observational records but developed different mathematical frameworks. The specific Babylonian computational methods were buried in clay tablets that were not translated until the 20th century, when researchers discovered that the mathematics they contained was more sophisticated than anyone had expected. Modern astronomers still use Babylonian observational data. The longest continuous astronomical record in human history runs from approximately 800 BC to the end of the Babylonian period, over 4 centuries of nightly sky observation, whose records survive and whose data is accurate, enough to be used in current research on the long-term variation of Earth's rotation. Number 6. Medical diagnosis. The Babylonians developed the first systematic approach to medical diagnosis, the practice of identifying a disease by its observable symptoms rather than attributing illness exclusively to supernatural causes. The Diagnostic Handbook, a Babylonian medical text compiled around 1000 BC and distributed across multiple clay tablets, organizes symptoms by body part and describes their implications for prognosis. It establishes the principle that a physician examining a patient should assess observable physical signs, the color of the patient's face, the nature of their breathing, the appearance of specific body parts, and use those signs to identify what is wrong and predict the likely outcome. This is clinical diagnosis, the logical framework underlying every medical examination conducted today. Observe symptoms, identify pattern, determine condition, predict outcome, appears here for the first time in any surviving document. The text also demonstrates awareness of contagion. Several sections describe conditions that should lead the physician to avoid treating the patient or to isolate them from others. An understanding that some diseases can spread between people that predates the germ theory of disease. By nearly 3,000 years, Babylonian medical practice was absorbed into later Near Eastern traditions and influenced early Greek medicine. But the specific diagnostic framework of the Diagnostic Handbook was lost with Babylonian literacy. The texts were buried in sites across Iraq and were not translated until the 20th century. When Assyriologist Nils Ekblad and later Markham Geller of University College London produced comprehensive translations, they found a medical text whose logical structure was more systematic than anyone had expected, and whose approach to clinical observation was recognizable to modern physicians in ways that later ancient medical traditions were not. Number 5. Insurance. This is the halfway point of this video, and the inventions that follow are the ones that change how you think about who you owe your daily life to. If you are not subscribed, now is the time. The Babylonians invented insurance. Not in a metaphorical sense, in a specific, documented, contractual sense. The Code of Hammurabi, the Babylonian legal code, dating to approximately 1750 BC, and one of the oldest surviving legal texts in the world, contains provisions establishing what modern legal scholars identify as maritime insurance. Babylonian merchants financing trade expeditions to distant markets could purchase a specific type of loan called a bottomry loan. Under a bottomry agreement, a merchant received funds before departure, and the obligation to repay was contingent on the expedition's safe return. If the ship was lost at sea, the debt was canceled. The lender, who charged a higher interest rate to compensate for this risk, was functioning as an insurer accepting the financial risk of the voyage in exchange for a premium embedded in the loan terms. This is the logical structure of insurance: the transfer of specific financial risk from one party to another in exchange for a payment. The bottomry loan documents it in explicit, enforceable contractual terms. The concept disappeared from explicit practice when Babylonian commercial law was absorbed into Persian and later Greek administrative systems. Maritime insurance was effectively reinvented in medieval Europe in Genoa in the 14th century, where merchants facing the same problem of financing high-risk sea voyages developed the same solution. The Genoese merchants who wrote the first European insurance contracts in 1347 AD were solving a problem that Babylonian merchants had solved and documented and enforced in clay tablets 1700 years earlier. Lloyd's of London, the oldest continuously operating insurance market in the world, is the institutional descendant of a contractual mechanism invented in Babylon. Number 4. The recipe. The oldest recipes in the world are Babylonian, 3 clay tablets held at Yale University, dating to approximately 1700 BC, contain detailed culinary instructions for the preparation of 25 dishes, broths, stews, and roasted meats, written in a format that modern cooks would recognize immediately. The ingredients are listed. The preparation method is described in sequence. The expected outcome is specified. These are not religious food offering descriptions or agricultural inventory records. They are cooking instructions written for the purpose of enabling someone to reproduce a dish by following the recorded steps. Assyriologist Jean Bottero of the École Pratique des Hautes Études, who produced the first comprehensive translation of the Yale culinary tablets in the 1987 book The Oldest Cuisine in the World, described finding instructions for dishes of genuine sophistication spiced broths that used onion, garlic, leek, and various herbs in combinations that produce flavor profiles recognizable to a modern palate. He and a team of professional chefs attempted to reproduce several dishes from the tablets. The results, by their account, were edible and in some cases genuinely good. The written recipe disappeared as a distinct document type after Babylonian civilization ended. Greek and Roman culinary texts exist, but are less systematic. The first European cookbook, Apicius's De Re Coquinaria, from the 4th century AD, appears nearly 2,000 years after the Yale tablets were written, using a similar format. The oldest existing recipes are approximately 3,700 years old. They are in a university archive in Connecticut, and the dish they describe would not be out of place on a modern menu. Number 3. The Flood Narrative. The biblical story of Noah's Ark was written down in Babylon. This is not a theological claim, it is a textual one. The Epic of Gilgamesh, the oldest substantial work of literature in human history, composed in Babylonian Mesopotamia and dated to at least 2100 BC, in its earliest known version, contains a flood narrative whose structural and specific details are so close to the Genesis account that scholars have debated the relationship between the two texts for over a century. In the Gilgamesh flood narrative, a man named Utnapishtim is warned by a god of an imminent flood that will destroy humanity. He is instructed to build a large boat, load it with animals, and wait out the flood. The boat comes to rest on a mountain. Utnapishtim releases birds to test whether the waters have receded. The last bird does not return. Utnapishtim exits the boat and makes offerings to the gods. The correspondences with the Genesis account are not general, they are specific and sequential. The warning, the boat, the animals, the mountain, the birds, the offering. Biblical scholars and historians now broadly accept that the Genesis flood narrative derives from Babylonian literary tradition transmitted to the Israelites during the Babylonian captivity of the 6th century BC. The Gilgamesh text was lost when Babylonian civilization ended. The clay tablets on which it was written were buried in the ruins of Nineveh. In 1872, British museum scholar George Smith was working through the Nineveh tablet collection when he found a fragment that contained a flood story. He reportedly became so excited that he left the building and ran through the street. He had found the source text of one of the most widely read stories in human history. It had been buried for over 2,000 years, and when it was read, it turned out to predate the version that Western civilization had been treating as foundational by approximately 1,000 years. Number 2. Ghost Stories. The oldest ghost story in the world is Babylonian. A clay tablet from ancient Babylonia, dated to approximately 1500 BC and held in the British Museum, contains a specific and practical instruction. If you are being haunted by the ghost of someone who died with unfinished business, this is how you help them pass on. The tablet describes the ghost situation: a dead person with no one to perform burial rites, no family to leave offerings, no name being spoken, and provides a ritual procedure for addressing it. This is not mythology. It is not a religious text in the general sense. It is a problem-solving document for a specific paranormal situation, written with the same practical tone as the medical and legal tablets of the same period. The tablet was translated in 2021 by Assyriologist Irving Finkel of the British Museum, who noted in his translation that the text describes a specific and recognizable ghost archetype, the restless dead, who cannot move on because their earthly affairs are unresolved, that appears in virtually every subsequent ghost tradition in Western and Near Eastern culture: the Japanese onryo, the Roman lemures, the Victorian ghost story, the modern horror film trope of the spirit that cannot leave until something is resolved. All of them are variations on a character type that a Babylonian scribe described and provided a remedy for approximately 3,500 years ago. The oldest ghost story is also a how-to guide. The Babylonians did not just invent the ghost story. They invented the ghost story with a practical resolution. Number 1. The world's first empire. The concept of empire, the deliberate, systematic organization of conquered territories into a single administrative unit governed from a central authority, was a Babylonian invention. The Akkadian Empire, which preceded Babylon and from which Babylonian civilization drew its administrative framework, was the first in history to attempt this. Sargon of Akkad, who founded the empire around 2300 BC, did not simply conquer neighboring city-states. He replaced their local administrations with centrally appointed governors, standardized the language of administration across all territories, created a professional standing army, permanently maintained rather than raised for specific campaigns, and established a postal system that allowed centralized communication across a territory stretching from the Persian Gulf to the Mediterranean. These administrative technologies, the appointed governor, the standardized administrative language, the professional military, the state communication network are the operating system of every empire that followed. The Persian Empire used them. The Roman Empire used them. The British Empire used them. They are still used today by every nation-state that administers territory too large for direct personal governance. The concept of empire disappeared when the Akkadian Empire collapsed around 2100 BC, but the administrative technologies it developed were inherited by its Babylonian successor, which refined and extended them. And from Babylonian administrative practice they passed into Persian imperial administration, which passed them into the administrative traditions of every empire that followed. Every government that administers a large territory, every federal system, every colonial administration, every multi-region state is operating on administrative technologies developed in Mesopotamia between 2300 and 500 BC. The concept of governing more territory than one person can personally oversee was invented in ancient Iraq. Every nation-state alive today is its descendant. 10 inventions, all of them Babylonian, all of them disappeared. All of them came back, not because they were rediscovered from Babylonian sources, but because every complex civilization eventually faces the same problems and reaches the same solutions. The sexagesimal clock, trigonometry for surveying land, the world map, astronomical prediction, medical diagnosis, insurance, the written recipe, the flood narrative, the ghost story, the administrative empire. None of these appear in the history curriculum as Babylonian inventions. They appear as things that simply exist, as if they always have, as if they emerged from the natural order of the world, rather than from the specific decisions of specific people who lived in a specific place 4,000 years ago. They were not always there. Someone made them, and for 2,000 years, while the civilization that made them was buried under the deserts of Iraq, the world forgot and reinvented everything Babylon had already solved.